Hi guys, sorry I couldn't be in class today. What I'll do is I'll just go and do a quick screen recording of these last couple of examples from our data that we're analysing to get our correct adaptation responses. Then hopefully you'll be right to go ahead and do the rest of your booklet and your practice sacks. Okay, so we'll have a look at these last few examples, which was in the booklet I gave you yesterday. Okay, so question 5 has a table in this case, so we need to analyse the table, and it shows the difference pre and post an aerobic training program. Okay, so it lists our cardiac output and heart rate at rest and maximal exercise, and what the results were pre and post training. Okay, so what we can tell from the table, okay, is we compare between the two. So cardiac output at rest pre and post training is unchanged. Cardiac output at maximal exercise, however, is increased. Heart rate at rest has decreased from 82 down to 58, and heart rate at maximal has decreased slightly. Okay, so the question, in terms of our question, the question asks us, by referring to heart rate and stroke volume, give reasons for the results shown in the table above. Okay, so here's where we need to show our knowledge of being able to analyse the table, and then also the explanation around why that would happen. So what was just analysed there before is the table. And we'll do rest first of all. The table shows that cardiac output is unchanged at rest and heart rate decreases at rest. Okay, so we've kind of shown our knowledge of what's happened in the table. Now I need to really provide an explanation. So the explanation, and as you would know from our other sections, is that cardiac output equals heart rate times by stroke volume. So therefore, if my cardiac output is unchanged, okay, at rest, and my heart rate decreases at rest, then something must be making up for it, and that of course will be our stroke volume. So here's where we show our knowledge of this part of it. So this indicates that stroke volume must increase to allow the same amount of blood pumped per minute, which is our cardiac output, with less beats. Okay, so I've just provided an explanation there of the reasons for the results at rest are that cardiac output doesn't change but heart rate goes down, therefore stroke volume must go up. The second part of this is that that cardiac output at maximal exercise, sorry this isn't quite on the lines, but cardiac output at maximal exercise increases, however heart rate does not. And again, this can be explained by an increased stroke volume at maximal exercise. If you really wanted to, you can certainly put in some figures. Okay, so the table shows that cardiac output is unchanged at rest, so we can certainly put some figures in there, such as 6.2 litres and 6.1 litres, but probably not necessary for this question as long as you're showing your knowledge of those results. That's probably a 4-mark answer. I've been able to refer to heart rate and stroke volume. I've mentioned both those in my answers, give the reasons for the results in the table above. I've shown my knowledge of the table, and I have obviously given an explanation around why this is happening. Okay, so that's the first example. For the second example, the other example I want to show you is you might get a example of a training program or example of a training session using one of the training methods. So here we got just a question around Mitchell Johnson in a 9-week preseason leading up to a tour. We've got exercises here, as you can recognise them, weight, sets and reps. So the first question just asks us what training method is this program utilising, okay, and we're obviously going to say that it was resistance training or weights training. Is fine for that answer for 1 mark. Okay, and then the other thing you might be asked to do as part of this is analyse that and say, okay, looking at the variables within our resistance training session, I need to say what program specifically should I target. So if we have a look at the information here, the weight is really high, so it's 90% of 1 year 1 repetition maximum. All the sets are between 3 and 6, would they normally be for all of them, but we've only got 4 repetitions. So I'm looking at a high weight and low reps, okay, which if you looked at your table would certainly say that we're definitely training muscular strength for that one. So that's the other type of data you might get, an example of a training program or an example of a training session, and you just have to be able to analyse that. You might have to pick up some errors in it, you might have to say how to overload it. Those are the kind of things you'll be asked to do for that. That's just one example there. Moving on to the last example here, which was a bit earlier in your booklet. A little bit different. This is probably one I haven't seen a lot of, but it's good to be ready for these kind of things. So it's a segmented bar chart, which you don't need to know the name for that, but it's got 12 months of aerobic training there, and we're talking about fuel usage. So the information we get there, and this isn't actually black and white, but you'll just have to go by the order of them. The fats are the purple, okay, and they're in terms of free fatty acids and triglycerides, and carbohydrates there are your glycogen and blood glucose in the maroon and blue. Okay, so we're again comparing trained to untrained, okay, and what the difference is there. So you can clearly see there, all I'm looking for is the changes. So this definitely increases, okay, so even if you want to write a note before we answer the question, so we're looking, there's an increase in fat usage, okay, both the free fatty acids and the triglycerides of both, the usage of those has both increased, okay. With this part, we're using less glycogen, we're using less glucose, okay, so we're looking at let's just say carbohydrates. So it's got clearly discussed the effect aerobic training has on fat utilisation and how this muscular adaptation would lead to improved endurance performances. Okay, so this is testing our knowledge really of how the body uses fats and carbohydrates when you're trained and untrained. So basically, it's looking for, first of all, it's looking for your knowledge of the data there, okay? And so what effect does it have on fat utilisation? So there is an increase in the utilisation of fats for a trained athlete. Okay, that's the main part of it. Okay, so that's really the chronic adaptation that we're looking for. On our summary, we've got it listed as an increased oxidation of fats, which now we're looking at our definition and how it improves performance. Okay, the second and third parts of our summary sheet. So increased oxidation of fats. You've got to show your knowledge of how that actually takes place. Okay, so there's an increase in oxidative enzymes, which leads to greater breakdown of oxygen using fuel. In this case, we're just talking about fats. Okay, so this increases our, and this is now how we're looking how to improve performance, and there's a couple little elements to this. The main part is that it increases our utilisation of our fats stored in the muscle. Okay, for aerobic respiration and energy production. Okay, it also, as on top of that, it also has a glycogen sparing effect, which would benefit endurance athletes. Okay, so the 3 parts probably to that for your marks there was the first part is really just clearly discussing the effect aerobic training has on fat utilisation. So increasing the utilisation of fats for trained athletes, we've explained that, and then we've also explained how that happens through increased oxidation of fats, increasing oxidative enzymes, which leads to a greater breakdown of oxygen-using fats, increases utilisation of fat stored in the muscle for aerobic respiration and energy production. So I've got a greater energy production anyway, and then it also has on top of that has a glycogen sparing effect, which would benefit endurance athletes. That's plenty of marks there. You've picked out what the chronic adaptation is. You've given the definition. You've said how it's improved performance, and you've shown obviously your use of the data there. Exact data is not important. It's just what the trend is. Okay, so there were the 3 examples I think that were left in your booklet, and I've shown you how to use those ones. You now need to go ahead and just complete those ones on your own using the help of this video. Then you'll need to, by the end of Thursday's lesson, just completed that booklet for me, or as much as you can, that's fine. And then I've also left 2 practice sacks as well. Okay, thanks very much for that, guys, and I will see you on Thursday, hopefully on Thursday afternoon.